Now consider an example. Show that f of xy equal to x square plus y square sine of 1 upon under root of x square plus y square if xy is not equal to 0 0 and equal to 0 if xy equal to 0 0. So that f is differentiable at 0 0. F is differentiable at 0 0. Now when we said a given function f is differentiable at x0 y0 if your increment function can be expressed in the form of ah plus bk plus h epsilon 1 hk plus k epsilon 2 hk, where a is equal to f of x at x0 y0, b is equal to f of y at x0 y0, epsilon 1 hk epsilon 2 hk tends to 0 as hk tends to 0 0. So first consider an increment function. So what is the increment function at 0 0? So del f is equal to f of hk minus f of 0 0. But since f of 0 0 is 0, so f of hk minus f of 0 0 is what? It is only f of hk, and therefore del f is equal to f of hk, which is equal to, what is f of hk? It is equal to what? H square plus k square sine of 1 upon under root of h square plus k square. H square plus k square. This function can be written as h square sine of 1 upon under root of h square plus k square plus h square sine of 1 upon under root of k square. H square plus k square. This can be written as 0h plus 0k plus h into h sine 1 upon under root of h square plus k square plus k times k of sine 1 upon under root of h square plus k square. Okay. Where here we are going to show that our a is 0, b is 0, and this is what epsilon 1 hk, epsilon 2 hk. Where now consider first a, which is equal to f of x 0 0, f of x 0 0. That is, we are going to show that here our a is 0. If you observe, our this side is same as this side. If you simplify this, again you will get the same f of hk. So आपण काही नवीन काही त्यामध्ये टर्म ऍड किंवा सेपरेट केलेले नाहीये, ती सेम टर्म आहे. याला जर तुम्ही सिम्प्लिफाय केलं पुन्हा अगेन यू विल गेट द सेम टर्म h स्क्वेअर प्लस k स्क्वेअर. मी थॉट आपण ह्या f ऑफ इन्क्रीमेंटला आपण कसं लिहिणार आहे, ah प्लस bk प्लस h एप्सिलॉन 1 hk प्लस k एप्सिलॉन 2 hk. मग इथे आपल्याला काय काय प्रूव्ह करायचंय की आपला फर्स्ट पार्शियल डेरिव्हेटिव्ह हा 0 आहे एट f ऑफ विथ रिस्पेक्ट टू x 0 आहे, पार्शियल डेरिव्हेटिव्ह विथ रिस्पेक्ट टू y हा 0 आहे, आणि एप्सिलॉन 1 and एप्सिलॉन 2 tends to 0 as hk tends to 0 0. So here what is a, f of x 0 0, it is equal to limit h tends to 0, f of h 0 minus f of 0 0 divided by h. So it is equal to limit h tends to 0, what is f of h 0? So y 0, so it is equal to what? h square sine of 1 upon under root of h square, this whole divided by h. So 1 h will get cancelled here, and it is equal to limit h tends to 0, h sine 1 upon under root of h square. So since it is multiplied by h, multiply, if it is not h, then this limit does not exist. But if you observe here, 0 multiplied by any term, so this whole term is equal to 0 as h tends to 0. So here a is equal to 0. Similarly you can show that b, which is equal to f of y 0 0. You put we take f of y 0 0, then here it is 0, here it is k, here it is divided by k, it is equal to k square, k is divided by k, 1 k cancel here, limit k tends to 0, limit k tends to 0, it is equal to k divided by sine of 1 upon k square. So again it is equal to what? 0. So b is also 0. So a 0, b 0. Now next there is only one condition left. Then we can say that the given function here is differentiable at 0 0 is that we want to show that here our epsilon 1 and epsilon 2 tends to 0. So what is the epsilon 1 hk? Epsilon 1 hk is equal to h sine 1 upon under root of h square plus k square, and epsilon 2 is equal to epsilon 2 is equal to epsilon 2 hk is equal to k sine 1 upon h square plus k square. Now as limit hk tends to 0 0, limit hk tends to 0 0, since this is a bounded function, sine is a bounded function, and as hk tends to 0 0, this h tends to 0 0, that is limit hk tends to 0 0, h is equal to 0, and sine is a bounded function, sine theta is less than or equal to 1. Similarly, limit hk tends to 0 0, k is equal to 0, and sine is a bounded function, and therefore as hk tends to 0 0, this epsilon 1 tends to 0 and epsilon 2 tends to 0. So we express our increment function del f as in the form of del f is equal to, how we express the del f? Del f is equal to, we express our increment function del f as ah plus bk plus h epsilon 1 hk plus k epsilon 2 hk, where a is equal to f of x 0 0, b is equal to f of y 0 0, and epsilon 1 epsilon 2 tends to 0 as hk tends to 0 0, and therefore we can say that the f of xy is differentiable at 0 0. So hope you understand.